Hi everyone, welcome to this panel discussion where we will discuss confidential computing. I'm Jürgen Beck, a distinguished engineer at Linaro. I've been working with various security things, and confidential computing is definitely an area that we are going to look into. So I'm pleased that I got the opportunity to moderate this session. It's a 45-minute session, and feel free to ask questions as we go on, and you can post them as chat messages in the Pine tool. And towards the end, we will open up to take questions from the floor directly as well. For the questions that we are unable to answer right away, or even by the end of the call, we will follow up by posting them in a Q&A that we will share with all the viewers. And the goal with this panel, well, for you who are already been at the sessions, I mean, we have covered quite a bit already, but we want to explain a little bit more what confidential computing is from a user point of view, how companies use it, and so on, and why confidential computing is important and relevant, and why now, for example, and a little bit about standard bodies and so on. So with me today, I have people from Google, ARM, Enarx, CCC, and Microsoft. So we will start with some introductions. So Nelly, could you?
Hello, I'm Nelly Porter. Thank you so much for inviting me to this panel. My role in Google is cloud security with cloud in the organization. So I'm working on different areas as it's helping to protect and keep customers' workload safe when they decided to move to the cloud. And those areas definitely including confidential computing. So looking forward for lovely conversation today.
Thanks. Charles, people have probably already heard from you, but could you please reintroduce yourself?
Sure. I'm Charles Tubin. I'm an architect and fellow in the Architecture and Technology Group, and I lead the confidential compute architecture.
Thanks.
Thanks.
Mike?
Hi, yeah, I'm Mike Bassell. I'm one of the co-founders of the Enarx project, which is an open source project which is part of the Confidential Computing Consortium, which is a Linux project which is aimed at encouraging use of open source in confidential computing.
Great, thanks. And Leonard?
Yeah, I'm Leonard Van Doren. I am within Microsoft Azure, where I'm responsible for getting ARM into Azure itself. As part of that role, I also have been very actively working with ARM on technology development. One of them is obviously around confidential compute, which we've been working on together for the last 6 years. And I'm working on all sorts of other interesting technologies, all the way from disaggregation to new kind of architecture features.
Right. All right, thanks. So when it comes to security, I mean, we have been able to deal with data at rest, data in transit for quite a while. And what we're talking about now is data in use. So what is really confidential computing? I mean, is the concept understood by the market? What do you think, Mike?
Yeah, so Confidential Computing Consortium was set up exactly to address these issues. And it has a definition, which I think is being actually pretty well accepted now by the industry, which is confidential computing is the protection of data in use by performing computation in a hardware-based trusted execution environment. Which fits very well with kind of the reason we're all here today, I guess.
Right.
I want to add something, if it's possible, because both of us, again, in Confidential Computing Consortiums that we created 18 months, one interesting fact that I want to add that this definition sounds so obvious, took us quite a bit to come up with. So I'm really glad that we agreed on definition, even we had to open conversation about what is TEE. So it's follow-up reference to something that probably everybody else already understood.
Absolutely. And one of the things that some of the definitions came up with originally was in the cloud, and we rejected that. We felt that it goes a lot broader than that. The edge, certainly, but beyond that as well. And again, this, I think, fits rather nicely with the conversations we're going to be having today.
Right. So confidential computing, that's not the new thing that we have kind of coined now for this new architecture and so on. It's something that we have been doing for a while in other environments. So,
yeah.
So from a company point of view, I mean, cloud is one thing that most of us see as the use case, as you said, Mike. But I mean, what are the benefits otherwise for this? I mean, if I, for example, have my mobile phone today, if I need to do work, it's not uncommon that someone throws me a corporate phone. Can I kind of get rid of that and continue to just use my private phone now, since we introduce confidential compute? So what are the benefits for the companies and so on?
Jim, did you take that one? Ready?
So I can pick this question simply for starter. So we do have, again, business phones and personal phones to separate and isolate our world to work and, again, leisure and pleasure and everything that we do outside of the work. But confidential computing provides as a strong level of isolation. We're talking about sometimes cryptographic isolation or cryptographically enforced isolation between different domains, between different worlds. And using confidential computing on mobile devices or on edge devices is incredibly powerful paradigm. There are multiple aspects. I think ARM has introduced trust zone, but something that was also targeting the same or similar use cases when very sensitive workloads or sensitive applications needs to be separated from the normal untrusted world, and only those applications had these higher privileges and opportunity to execute something. So I think it's continuation of the same model, but much more, again, general purpose that allow us to, moving forward, to provide, again, from very small use cases, as you said, on mobile devices, to running enormously scalable workloads in the cloud that before simply were not even feasible to run in this isolation environment. And to be able to scale from the small use cases when we're talking about like key protection or very, very sensitive, again, trustlets running in those isolation environments, to running the whole entire, I don't know, Spark or Hadoop in confidential environment, because it's happening that those workloads are actually touching sensitive data. It's a transition, and again, the journey that we are making from all of those smaller environments to, again, environments that will be as powerful as general computing environments we're familiar with.
Right. So
I completely agree, Nelly, there. It's about providing logical and physical isolation. And then what the new technology does, it actually makes that a more generic concept. So it's not something that runs underneath an operating system. No, it's on the same level as an operating system. So you can run the same type of VMs that you would normally run on a hypervisor, but you now get more isolation guarantees. And as I said, it's about logical and physical isolation.
Absolutely true.
right.
Sorry, guys, this is not actually meant to be a question, but we're getting a lot of reports of echoes, and some of you guys are a bit hard to hear. So could I ask folks, if you're not speaking on the panel, to just mute to see if you can make the echo go away?
Sure. So Linaro, yeah, Microsoft and Azure and so on, it's a big company. So can you kind of give a couple of examples how you are going to use this new technology, or maybe?
Yeah, absolutely. And as you're probably already aware, right, we already ship confidential computing as a product offering and a service offering. And we're seeing a lot of traction from like healthcare, right, which is unfortunately only too relevant in the current day and age. So we're seeing things around disease diagnostics, drug development, contact tracing, all these kinds of things where you want to share data, but because of things like regulatory compliance issues, it's very difficult to go and do that in a generic environment because you can't enforce the patient privacy and all these kinds of things. Having that isolated environment where you can run your database, right, where it is guaranteed to be isolated from everything else, and the trust relationship is really between the customer of the virtual machine and the silicon provider, and everything that sits in between is taken out of that trust relationship, is extremely powerful. We're also seeing a lot of interest from financial services, right? Banks. Again, people there are interested in digital currencies, secure payments, protecting secure code, right? Some of the hedge funds codes or other proprietary algorithms that people use that they really do not want to have leaked. And then, of course, you got governments, right? Digital identity protection, critical infrastructure, judicial proceedings and case management, all these kinds of things where privacy is at the forefront. And so, yeah, this is just an overview of the kind of applications that we're seeing, and we're already seeing tractions on those applications today.
Plus one on everything that you said. And again, as Google Cloud also shipped confidential computing product to the market last year, and we've seen very similar use cases as well. But a few very interesting, I would say, a few additions that we started to see, not only this collaboration or again multi-party computation that you're referring to, but also again, people started to see confidential computing that applicable to even build environment. So with SolarWinds and secure supply chain, we again, honestly, in Google spent tens of years, I'm sure Microsoft as well, to protect the whole entire supply chain, because it's a lot of questions about dependency of my code that will run in confidential environment. Sorry. And what we see is the efforts of multiple companies and open source community to ensure that even the build system itself is running in confidential environments, and to ensure that signing those builds, signing those binaries cannot be tempered, cannot be altered, and ensures that every single time when you're going, and again, in our vault, when we're submitting anything to production, we have multiple LGTMs, multiple reviews, QA, blah, blah, blah. The whole entire set of steps that we need to go. And every single step is signature, because we want to ensure that integrity of this workload is verified. And what we see, interesting efforts coming from different build systems, trying to ensure that all of them also run in confidential environment to provide this isolation that you were talking previously as well. So yeah, very interesting use cases from very small to very big. Yes, Mike.
And I'd say it's difficult to think of sectors where it's not relevant. Every sector you can think of has either data that is sensitive and mustn't be changed, where the integrity is important, like the build system, or your legal documents or something like that, or information that needs to be confidential, whether it's your customer data, your payroll data, your legal data, your AI data, your research data, your exploration data, all pretty much any case you can think of. And I think we're going to be moving to a state. It'll take a while, it'll take a few years, where it's not, which of my workloads should I protect, but which ones would I not protect? Why would I not do this? I think we're going to be moved to a world where it's much more pervasive. Sorry, Linda.
Yeah, no, Mike, I completely agree with you, right? So Microsoft's vision is that we certainly have a little bit of a chicken and egg problem right now. We need to bootstrap this ecosystem. And of course, all the implementations right now do have performance implications, right? But as we're working through those and fixing a lot of those kinds of issues, our end goal is that we would enable this by default everywhere.
Yeah,
right.
Makes complete sense. I mean, at the beginning of my intro, I sort of put, I'm actually in the blog release today as well, I talk about this right of access and right to manage. And fundamentally, why the hell would a kernel or hypervisor have a right to access? It just doesn't make any sense. It was just a convenient thing to do at the time, but it's not really the right thing to do. I completely agree with that, but everything.
This might be a little bit weird question, and maybe you can't really give an answer, but how does this affect GDPR and things like that?
Yeah, well, I think first of all, we know that regulations always lag behind technology, so it's going to take a while for the regulators to catch up. But I really confidently expect that the regulators will start saying, as long as you're using it in an environment where you've got certain proofs and assurances that you're doing this, then it's okay in certain circumstances to put stuff in the cloud that you couldn't at the moment, for instance. And the Confidential Computing Consortium, part of their interest is working with regulators and legislators to explain why it's okay as long as you've got certain assurances put in place. And, it's tricky at the moment to use confidential computing for general workloads. We've got some amazing sort of bleeding edge folks, and it's great that the cloud service providers, Google and Azure and others, are making it available, but it's not easy to use for the company in the street, as it were. And I think that that's going to change. It's certainly the project I'm involved with, Enarx, is taking that very seriously. But I know that everyone in the industry is trying to make it easier for people to use it. And what's being announced here today from ARM is just going to broaden the reach of the technologies and mean that there's more available to use, and that's great.
Can I follow up on the Mike? Is it possible? So I think, Mike, you're raising interesting three questions, so three topics simultaneously. The first is how confidential computing helping privacy. And GDPR is one of the examples. And I think it's very much aligned and helping to provide more privacy preserving capabilities to multiple workloads. I think it's very related activities. We can't say that it's addressing every single checkbox of GDPR or any other privacy regulation. It's what we need to figure out how to map as a technology to compliance world, but it's definitely helping. And again, one additional interesting example I can bring to here is last year, by the end of the year, California come up with Privacy Act. I don't know if you've seen it. And it was very interesting provisioning that was actually very up to date. It's saying if you would be able to provide for me guarantees and evidence of your end-to-end encrypted workloads, then you would not have to pay a significant fine. So it was very clear definition that this technology can help, or some technology can help to address those compliance requirements. Point one. Point two, that Mike definitely will continue talking about, what are the proofs? How to verify this environment. And that's a very important aspect to auditors, to our users, to relying parties. Again, those applications, sensors, your mobile applications, if they're sharing anything with the cloud, they need to ensure that they trust this cloud. And trust is a very big word. So there is a need to establish those. Again, we will be talking about attestations and other mechanisms as a proof that you're talking to trusted execution environment. And the third topic that I want to repute, again, clouds understand that ease of use is paramount. And I think it's why Microsoft and Google, and I'm sure AWS, spending a lot of time to ensure that any workload can be brought up to confidential environments with ease, scale, and performance. We understand why we're providing our services to our customers, and we absolutely paramount to make it super easy for them to use this technology. It's our business. It's why we are. So, sorry, it's long answer, but I think those three questions, or minimum two of them, are very, very appropriate to our follow-up conversation.
So related to attestation, I mean, I was listening to Simon's talk about it, and there were some questions asked in the chat as well about TPM and such, and that was what I was thinking myself when I was reading it. So he mentioned about this HES. It's so Charles, can you kind of elaborate a little bit on that?
It's really just a handle to describe what a lot of implementations already carry today in terms of secure elements, and it's about storing and processing key materials in a place that's separate from the main application processes, so that you're not subject to side channels into that. So that's really all it is. It's just a handle for that, because there's a few different ways in which you could implement that.
Okay, because I was thinking, if you, for example, take the TPM as it's used today, you have the PCRs and you extend it to different things that you kind of attest and so on and measure. And to me, it seems like the realms are more kind of a runtime thing. So to me, it feels like it doesn't really fit into the TPM world today to extend it because of that.
I think it's both. And it's, again, for example, AWS that is not present today is, again, with their Nitro enclaves are using PCR and the TPM-like approach that more familiar to people to attest the environment, because you need to attest a few things. You need to attest that your environment and your workload that will run in this environment is integrity assured and has confidentiality. And you also need to attest that when it's continuously running in this environment, it's continued to behave as you expected. And I think there's a runtime attestation is much more complicated that industry still has to figure out, especially when it's coming to the huge workloads, because they're so not, again, immutable. They still have to change as they run. So it's definitely some work we need to do. But attestation, I think it's very important aspect. And we discussed so much the concept of attestation and necessity of interoperable attestation.
So we haven't defined what attestation is, and I think it's worth briefly saying. Basically, attestation is claims made about your confidential computing environment and what's in it, which are cryptographically backed. So let's say that I want to load an application into a trusted execution environment, into a realm. In this case, I want proof that what is in that realm is what I loaded, and also that it is a real realm and not someone just doing a software emulation and pretending, because that's pretty bad, right? And so attestation provides you with cryptographic assurances and a chain of checks that you can check. And I think it's important to point out that, because if you don't have that, you really just don't have the assurances that the confidentiality and the integrity mean anything at all. And so it's a key part of any confidential computing thing.
Yeah, absolutely. The two cannot be decoupled. They are connected, right? Because it's one thing to isolate the workload you're running. The other thing is, because you cannot look into it, you need to have some sort of proof. You need to have some sort of attestation of what is there. And I also want to echo what Nelly just said. It's not just about load time guarantees, which is what most of the traditional trusted computing group attestation models are. It's also about runtime guarantees, because when you have these long-running processes that run for years, right? If you've got a buffer overflow and a code injection attack, there's no guarantee what's running in it. What you started with may not be the thing that's actually running. So you need to have ways to actually attest this at runtime, so you can continuously get a measure, right, of what the property or the security properties are of what you're running.
And I think
yes, Mike. One additional point that I wanted to add, or one additional challenge. If you're running confidential computing on different CPU, again, there's different silicons, every one of them have their own specific type of attestation. And again, as we started this conversation and derailed slightly, TPMs also have their own style of attestation. And one of the interesting challenges that a confidential computing consortium trying to address, how to ensure that normal human beings would be able to understand those claims and don't need to have PhD in computer science or in any other secure related technology to be able to parse and verify those attestations. So it's why we started in CCC, Confidential Computing Consortium, special SIG, this working group together with ARM. Thank you so much for supporting, again, this effort. And it's called SIG Attestation, no surprise. Because you can imagine use cases when my data is, again, actually stored on Azure or any other on-prem, and I need to process it in Google confidential environments or otherwise around, how those services will interrupt and prove trustworthiness of the environment and, again, data, how they secure shared keys. So all of that is becoming a very interesting and challenging problem that we as industry together need to come And again, do not overwhelm our poor humans, our customers, and again, make sure that we will interrupt seamlessly when we have to. So I think it's an additional big challenge that we still have to go and figure out.
All right, so my background has been quite a bit with Trust Zone since I joined Linaro and so on. When I first saw this, I said, well, here we have yet another thing running on the secure side and so on. We're ending up with a pretty complex environment now, Charles. What do you think about it? Are we right thing?
So I guess the first thing that I'd say about that is we've actually built on Trust Zone and on the principles of Trust Zone and virtualization to simplify the hardware requirements significantly. So that's something I covered during my talk. There's a lot of RTL reuse here. But we did want to separate the environments because they are, separate use cases and separate practices. Some are more about platform security, whereas Realms are really all about third parties, being able to run third-party code, being able to run standard operating systems with standard workflows and standard tools, which we've talked a lot about even in this panel. An alternative we could have done is to try and chuck everything into Trust Zone, and it would have been incredibly complicated to reason about the security of a system where you have, say, IP that's designed to understand Trust Zone secure and non-secure messing around in the same physical address space as your realms with the same security stacks, right? Or imagine if I told you, as when you used to, as in your capacity of tech leading Opti, if I told you, oh yeah, actually you could run Opti alongside Linux and Windows in VMs around your Opti. How the hell would you reason about that? Right? So I appreciate that it looks complex, but it is a modal thing, and you're choosing between, effectively 3 different modes as you through the monitor. But actually, I think it's a far simpler alternative than if we try to.
Yeah, and I to sort of back up on that, I think that sometimes we assume that we're just layering security on security on security. And although defense in depth is important, actually one of the things that trust execution environments allow you to do is to remove some of those layers in terms of the trust model. So, we don't in this trust model need to rely on the underlying host operating system for the confidentiality and integrity. So there's a whole bunch of possible vulnerabilities in all of that stack, which we remove, right? There's also opportunities to reduce what you actually put in the TE. So if you don't want to run a full legacy VM, then you can cut that down and have a smaller sort of microkernel or a different runtime environment. So you can actually cut down what you're running. This isn't just more and more layers for there to be problems with. You actually have an opportunity to reduce your attack surface because you're reducing what's in the trust model. And so don't think this is just another thing to break. It's actually not. And because you can describe very carefully what your attack surface is and what the model of defense is, you're actually gaining a lot. So I think that's an important thing to sort of take on board when you're thinking about TEs.
I think that when you kind of put it into a smaller environment, it makes life easier for people working in automotive, for example, when they need to do safety certifications and things like that. So
exactly.
Yeah.
Hey guys, I'm hearing echo concerns again, so I'll just remind people about the mute thing, please.
In Charles' talk, we heard you mention a little bit about resources and so on, but confidential computing, is it only about CPUs? What do you think, Leonard?
No, and actually that's a really good question. So we started out with isolating, right, giving the isolation guarantees within the CPU because that's the building block. But as we're seeing more and more computational needs move to accelerators, like GPUs are clear examples, but you're seeing a lot of machine learning accelerators, you're seeing smart NICs, you're seeing video transcoders, So we're actively working about how can we bring those smarter kind of devices into the security fold, into the TCB. And there's a lot of standardization work actually happening within PCI Express and with CXL at this point. So this is not just an ARM problem, right? This is also an AMD problem. This is also an Intel problem. And so we've all come together and we are actually working and solving on this problem to solving this problem together. So yeah, this is not just about the processor. We're definitely expanding into the IO fabric and bringing these accelerators and other smart devices into the security fold. So a lot of these kind of technologies, right, are moving out into IO accelerators. And so this all becomes part of the same story, the same TCB.
To add to Leonard's point, and it's very important point, thank you so much, plus one on everything you said, that accelerators are part of confidential computing stories, there is no question. I want to bring it a little more use case, because when customers bring in AI, ML type of training inference models to cloud, and it's, again, huge workloads that we need to run, there is opportunity for them to utilize GPUs very effectively, not single GPU, but the whole entire rig of GPUs. It's like absolute monstrous device with multi-GPU environment. And to be able to do it now, if we will apply the goal that we have, that data is always protected when it's in use, we need to ensure that, again, as Linda said, between CPUs and GPUs are changing and kind of, again, going back and forth with the buffers of data that they need to work on. We need to ensure that, again, the whole system is actually supporting and respecting confidentiality. Starting from CPU and GPUs, they need to establish identity. They need to prove to each other that they actually trustworthy in this confidential world. They need to have the traffic over PCI Express bus, as Leonard said, encrypted, preferably. And they need to ensure when they can exchange and what they can exchange. And by themselves, they need to support confidentiality. It means their memory, their, function, everything needs to be attested. And also integrity and, again, confidentiality assured. So there is a significant amount of work with industry, and it's nobody's fault. We're simply, again, coming to the new era when necessity of this confidential computing environments becoming so, again, must have in upcoming years, and we need to ensure that our vendors are ready for that.
Yeah, and if you thought that doing attestation for a single trusted execution environment on a single, piece motherboard was difficult, you should try thinking about reasoning about adding in a GPU or an IO bus and in real time, or taking it out and how you attest and how you manage that and how you even record that. This is a really complex thing, which is why we're seeing starting off, with the CPU. But I absolutely am confident that we will see broader stuff. But there's a lot of work to be done around the trust model, the attestation, which is fantastic. If you've got any academics out there, there's lots of work to be done. So love to hear about it.
Let's see, we have like 11 minutes left. So let's have yet another thing before I open up for the floor. Open source community. I mean, how can we start to engage those people in this kind of discussions? Mike, what do you think?
Yeah, well, come along to the Confidential Computing Consortium. It's a great place to start, because there's already a number of open source projects which are part of the CCC. Enarx is just one of them. There's the Open Enclave SDK. There's a bunch of other ones which are joining at the moment, and so it's a great place to go and find out what's going on, but also for those projects to get involved too. And it's not just there's lots of big vendors in there. So all the big silicon vendors are in there. Most of the big cloud vendors are in there. Some big end users and some startups as well. But there's also opportunity for people who are looking to explore use cases to get involved as well. And so that's another thing alongside the SIG. that Nelly talked about that is being kicked off at the moment. So you don't need to be involved in writing code. I should be very clear about that. So it's not the only open way of getting involved with open source. But we'd love to see you. We'd love you to come along. Go to confidentialcomputing.io. I'm sure we can put out some information, but it's pretty easy to find. There's some really useful white papers around there as well. And ARM and Microsoft and Google are all very involved members in the CCC. So I know we'd all love to see you there.
To add to Mike's point, yes.
One quick thing is, you know, in the ARM ecosystem, we absolutely rely on the open source community, and actually, you know, we have a long and well-established relationship with Linaro, which is very much, you know, really established for that reason, right? And like I said earlier, one of the things that we wanted to do with this architecture is do open source reference firmware for it in trustedfirmware.org. So I think people looking at that, evaluating that, providing feedback on that's going to be super important. Equally, there's a whole bunch of upstreaming work that we're going to do into a kernel and into Linux and KVM, not just for the hosting environment, but also for in-realm. And so, you know, please help us and support us on that would be my kind of call to action on that.
And I think what I wanted to have one additional point. So one of the open projects that ARM submitted recently was around attestation. Again, it's usually had a very interesting name. So but it's specifically some proposal how to do this complicated topic and simplify it. So thank you so much for contributing that. And it's very, very important for us that open source community, in particular these confidential computing consortium, Linux Foundation, would be able to continue grow.
And my view, I mean, I'm an open source guy and have been for a long time, is that if you're going to trust the crown jewels of your organization, your most sensitive, important data to an environment, the more that is open source, the better, because it can be audited. It can be checked by the community. You can see it. Your colleagues can see it. So I think open source has a really important part to play in confidential computing.
And Mike, I completely agree with you. I was going to make a comment, right? If you run these containers, these VMs, and you know you're isolated from everything else, and you can attest to it, then clearly you need to have access to all the source code that runs inside this realm. In starts with whatever firmware layer is there, right? It starts with the operating systems that you run into. It runs with the applications, because in the end, yeah, you get an attestation statement, but only if you can relate it back to the source code, you know what it means, right? So yeah, I think open source is a very critical component.
Thanks. So let's have a look at the questions from the floor. So John Masters, he asked, what additional value do you see from architecture shared between client phones through edge to cloud? Mike?
If you can deploy the same applications using the same attestation mechanisms, and it all looks the same, there's a lot to be said for that, right? That makes life easier. There are, particularly until we get the attestation sorted across, having that across, having the same things is great. The other thing is that, you know, the ecosystem that, you know, Linaro and ARM bring to this means that scales very nicely.
And one additional very important use case. Yes, please. Delay.
Yeah, sorry, the audience seems to be breaking.
Please continue. Yes, no problem.
You go first, and then I'll finish.
Yes, thank you. One of the interesting use cases, specifically related to phones, is the necessity to share the very sensitive information from those phones with the cloud for processing. we see quite a few applications trying to use cloud environments to do some deduping of, again, very important address books of their users, or there's payment apps that are trying to, again, do approval of payments. And again, a lot of this consolidated, aggregated computation happening in the environments of cloud. So when mobile phones trying to share anything, or even, again, smaller IoT devices with cloud environments, the attestation and confidential computing is helping us to ensure that they talking to the right entity in the sky.
So we have one question.
Yeah, and the focus, and we've touched on a bunch of things, logical security, right? And security, and especially around the edge. If you start talking about cell towers or servers that sit on the street corner, right? That isolation aspect, that physical protection aspect is absolutely critical in those environments.
IoT and on gas pipelines and in stadiums and everywhere. We're going to see more and more of this. And anything which is physically vulnerable, to be able to know you've got a core piece of your environment where you can have assurances about it being protected, it's really huge. It's going to change how we think about moving stuff to the edge and out to IoT. And manufacturing and stuff. We're just going to think differently. It doesn't all need to be in your big data center anymore, because that's the only place you can protect it. Because we can now start protecting stuff much better, far further out to the edge, and that's huge. It's just a new way of thinking about security now.
Right. All right, so we have another question here from Marno van der Maas. Why did ARM choose to create realms on the VM granularity as opposed to on a process granularity? I think that's for you, Charles.
That should be me. So, the architecture that we created met the threat models that we originally discussed with our partners. But, we do understand threat models evolve, and actually we are going to be looking in future architecture releases at adding granularity that goes beyond realms. It kind of depends on your deployment. For some deployments, there's actually quite a lot of benefit of being able to have lighter weight encryption in that sense, and being able to do things like sharing code, sharing data, for example. For other environments, and there are threats that don't particularly apply in those environments, that having per realm keys, which is the internal nomenclature that we have for it, don't particularly help in solving. But for other environments, we do see that's important. So whilst it's not in the architecture releases you see today, I can tell you now that there will be architecture releases in the future that will add that.
And I think it's worth pointing out that sometimes when people think VM, they think a whole, Linux OS image, whatever. By VM, we mean a virtual CPU and some memory pages, right? It doesn't mean you have to shove your whole application in it. You can actually put very small stuff. It's the approach that Enarx takes, the approach that a number of other projects take. You don't need to be stuffing everything in. So VM doesn't immediately mean this huge monolithic, bloated thing. Don't think that at all. I mean, I suspect that the person who asked that question wasn't thinking that, but I think it's worth being clear that a VM can be very, very small. So that's, don't assume big. It can be tiny.
Absolutely.
So I think we have one last question, and I think I will hand this over to you, Lindert. Please compare ARM security approach to the other approaches from, say, Intel and others.
I think that Charles already touched on a few of them. I think that at a 10,000 feet point of view, right, it's around isolating virtual machines. But as Mike said, right, this is not virtual machines in the traditional sense. It's really as it exists at the hardware abstraction layer, right? So very fine contained virtual CPU and some memory pages, asynchronous events, that kind of stuff. So you can build all sorts of things in that. You can build containers in that, VMs, whatever kind of concepts you want to create. In that sense, what ARM has is very similar to what AMD has and what Intel is doing with TDX. And that's a good thing because it makes it much easier to go and build interoperable environments. Intel also has an enclave notion, right, which is really about protecting part of the process. As Charles said, something like that may come to ARM. It's a more complicated model to work with because now you actually have to change your software in pretty fundamental ways. You have to take within a single program, figure out what is secure and what's not secure. And that requires quite often a significant rewrite. Still, it's an interesting technology for a set of use cases. But in general, oh, say that again. We're done.
So yeah, so we're running out of time now. So
Okay.
Wrapping up this session now. As I said, the remaining questions that we have will be answered and will be posted afterwards. I also would like to say thank you in the panel here for taking the time to show up, and especially you, Leonard, in the middle of the night. So, and I also would like to say thanks to Christine and other people who organized this. So yeah, thank you everyone and have a great day. Bye.
Thanks everyone.
Thank you.
Bye-bye.
Bye.